All right, cool. So I'm going to get started. Welcome, guys, to my workshop, which is called Getting Started with C. This is, of course, the third time I've done it. First time wasn't too bad, but I forgot to record it. Second time was really bad, so nobody's ever going to hear that or see that recording. And hopefully this one's going to be the best of both worlds. So, I think we'll be all right. The Mac goes all right. It's not too noisy in here. I think it'll work. Yeah, that's cool. Hopefully I don't need to do it again just for that reason. But I'll just turn it up, it'll be all distorted, and that'll be fine. No, I think it'll work. But thank you. All right, so what are we doing? We're getting started with C. In particular, we're getting started with C at 42. And that means that we have a project to do, and it's called C00. This is where our journey starts. So, what we have on our intro, as we should all be aware by now, is a project page where you can see and subscribe to projects. Now, in order to get to this point, you probably need to have submitted at least one thing, but let's hope for now that we're all at least up to the point where we can subscribe to C00. And we'll see a page that looks like this with a link that says See My Project Page. When we click that link, we get a bit more info about that project that's just for us. We don't have a lot, but we have a PDF, which is our subject PDF, that tells us what we're doing. We have a link to some 42 videos, which we assume are related to the tasks that we have to complete. And we also have this Git repository link. Now, this is important because this is how we are going to submit our work to 42 so that they can grade our C00 project. Now, there's a few questions to unpack straight away here, because what this is what it says it is. It's a Git repository, and it's a link to a thing called VogSphere. So very quickly, what is Git? Well, Git is a set of tools that we're using as software developers so that we can keep track of our changes, and we can also collaborate with other developers so that when we're both making changes, we can see what's happening and work together with our independent progress. So the way that we do that is that we have a local copy of all of the data in that Git repository, which is just like a folder for your work in Git speak. And that repository also has a remote copy. And the way that Git basically works is that you push your changes to the remote repository and you pull other people's changes to your repository so that you can keep your code base in sync. That is, all of the code that you're working on together. Now, in this case, we're only really doing that for the Rush group, and perhaps we're coordinating things in such a way that only one of our group members is pushing. So the collaboration aspect is not so important for now, but it's worthy of mention because in the future, not if, but when you are working as software developers, this will be a very big part of your job. This will be how you all sort of work together. So that's what Git is. And then the other question to unpack here is, what is VogSphere? Well, VogSphere is just a name that 42 have given to their Git server. So whenever you have a remote repository, that needs to live on a server somewhere. And that's what VogSphere is. It's the Git server for 42 Adelaide. And in fact, you can sort of see a few more clues to that in the full domain name there. So yeah, that's it. That's our Git repository. And by pushing our changes, that is, by doing stuff and pushing it up to this Git repository, is how we're going to submit our work. So that is basically all the relevant stuff that we get from our project page here. The most significant part of that, of course, is the PDF. So let's jump into that now and see what else we can learn from there. Now, like most people, I'm guessing, I skipped over this instructions page very quickly and was part of a lot of discussions about things that may or may not be facts with other people around the school. And only when I actually read this, I saw this kind of hilarious note. Only this page will serve as reference. Do not trust rumors. I'm now starting to wonder whether our mentors are purposeful in telling us things that aren't accurate so that we will be forced to follow these instructions. But anyway, that's just a conspiracy theory. But there are some other clues here. We have some notes like things that Norm and Nat are going to do. One of these specific notes, which I definitely missed early on, is this one here. And there's been some conjecture and, dare I say, some rumors about whether or not this is the case, but actually it says very clearly in the instructions we were given at the very beginning that you cannot leave any additional file in your directory other than is specified in the subject. I don't think that's necessarily true for shell, but we're not going to see it. I can go back and check shell to see if it's the same thing, but I'm inclined to follow these instructions. I'm probably just going to leave it at that. So, okay, good question. We have been told fairly categorically that the one exception to this is the .ds underscore store file that your Mac will automatically create anywhere you've been browsing in the Finder. So we don't need to nitpick about those, but suffice to say we should not be creating any other files inside the folder that we're submitting other than the ones that we've been asked for. So with that established, I'm just going to do a little bit of housekeeping before I even get into exercise 00. There's a bit more stuff in these instructions. I recommend you make sure you've read them all at some point in your own time. Now, before we even start EX00, I'm going to do some housekeeping. I'm going to set up a folder and figure out where my work is going to live so that I don't lose track of it. So very quickly, just going to see where I am. I'm going to jump into my desktop and into this folder. And I'm just going to go ahead and make a brand new folder for this project, C00. And I'm just going to go build because I already have two of those. Cool. Jumping into that folder now. Whoops. Jumping into the right folder now. Alright, here I have a workspace. Now, as I was just saying, when we submit our workbox here, we don't want to include anything else. But there's a bit of a process we need to go through to get to the point where we're confident that our work is ready to be submitted. So we're probably going to have to do more than just create, as we have been asked here, an ft_putcar.c file. So what I propose is that a good habit to get into is when you set up your workspace, give yourself a folder for each exercise and then separately establish a folder for your VoltSphere repository. That way, as you finish each exercise in your working directory, you can file away the files that have been submitted into VoltSphere, you can commit and you can push them so that they're saved to that server, and you have a backup, and then you can move on to the next exercise. You don't have to do it that way, but I think you will find that it's a really good habit to make life easy as you proceed through a large number of exercises for a large number of projects. So I'm just going to set up my EX00 here, but I'm also going to create a folder for my local Git repository, which is to say my clone of the Git repository that has been created on the server for that project for me. And that's referring back to this link that we started out with here. This one's on the project page. So I'm going to grab that link and create the folder for my local version of that repository. I'm going to type git clone, and that command is going to want me to give it that URL. And then optionally, I can also give it the name of a folder to create in my current working directory that I want to become this clone. So I'm going to go ahead and do that. I'm going to put VoltSphere in the name of that folder, just so that it's crystal clear to me when I'm loading stuff to submit that that is the work I'm submitting. VoltSphere C00. Cool. My local repo name. This looks a bit better. Hey, there we go. Now, if you're just starting the project, you're going to get a message just at the bottom here which says, warning, you appear to have cloned an empty repository. Now, that is totally normal if you're just starting that project, because that repository has actually just been created as an empty folder for you to put your work. So when you see that message that is totally normal. The reason I haven't received that message is because I've already started C00, and so there's already some exercises inside that folder. But let's just pretend for now that we're just starting out and that's empty, and that's cool. So now that I have my VoxSphere folder ready to go, and my EX00 folder to work in, I'm going to go ahead and jump in here and get started. So, what do we need to do for EX00? Well, we have been asked to write a function. We've been given some information already in the specifications of this exercise about how that function needs to work. Now, I guess normally as programmers, when we're writing a function, the first question we have to ourselves is, what does this need to do? How will I go about achieving this goal? But at the beginning here, we've been given some fairly sort of, I guess, strict specifications about what we're needing to do. So we need to start by, I guess, applying those specifications and filling in the gaps. So the information we have about the function that we've been asked to write is that it displays the character passed as a parameter, and that it is prototyped as follows. So straight away here, we need to unpack a few things to be able to use this information. So what we have here is the prototype for this function. Now, to be able to figure that out, we need to do a little bit of C functions 101. And that means that we need to be able to recognize a few things. I'm just going to get started here and create a main.c file. Now, we've been asked to write our code in a file called ft_quickcar.c. But as I was saying earlier, there's a bit of a process we're going to want to go through to get to the point where we're happy that that file and the code it contains does what we've been asked so that we get graded with a pass. Makes sense, right? So in order to be able to do that, we're probably going to want to compile a program. You can't really do much with your C code without compiling the program. And in order to be able to compile a program that's written in C, it must contain a main function. So in addition to the ft_quickcar function that we've been asked to write, if we want to create the bare minimum code to be able to run a program, we also need to write a main function. Now, we could choose to put that main function in the same file that we're writing for the exercise. That would be a valid choice for us to be able to test our code. And what some students have been doing, which is kind of a cool trick, is using what's known as a block comment to then comment out, which is the expression that you would use there, the code that represents their main function, so that when Moulinet reads that code file, it ignores that part. So I'm just going to show you very quickly how to comment out code in a way that Moulinet will accept, or that the Moulinet will accept, because that's a really useful trick. Commenting code is a really good practice to get into, and it may have been a frustration for some people who tried to comment their code that when they did // this is a comment on this line, that Moulinet will come back and say, no, you can't do that. Fortunately for us, Moulinet does accept one comment type, and it's what's known as a block comment. And instead of just starting the comment line with 2 slashes, you need to start the comment with /*. That can go over multiple lines. This is still a comment. But at the end of that comment block, you need to do the opposite of what you started it with and put //. So if you want to write notes to yourselves, or if you want to include extra code in your files, which you want Moulinet and Moulinet to ignore, you have the ability to use block comments in your code. So we could use this trick, and we could stick a main function inside our ft_quickcar.c file, and then just comment it out at the end, and that should be fine for submitting our work. But I'm going to do things slightly differently. I'm going to put my main function in a different file, and part of the reason I'm doing that is that we're going to need to test all of our functions that we write, and we have quite a few to write just for C00. So I'm going to try and create a main file that I can copy into my next exercise and use again, so that I'm not just completely reinventing the wheel. We should probably be getting practice as we go, but you know, it's a fine line between getting work done and practicing, so that's how I'm going to go about it. So just backing out of what I've done here, Now I've set up a main.c file here, but I'm not seeing any syntax highlighting yet, so I'm just going to try something. I'm going to get to why I've written that in just a second, but first of all I want to get my Vim to behave. Oops. So I'm going to try and set syntax. No. It's not recognizing it as a C file. Normally when you create a file and it has a name that ends in C, that's good enough for Vim to recognize that it's C code. Oh, yeah, is that what I did wrong? Yay, thank you, sir. So, syntax on and set number. These are my two favorite Vim commands so that I can get some highlighting of my C syntax inside a file that has a name that ends in .c, and also so that I can see the numbers of the lines down the side, which is really helpful when we run Normanet, which is going to tell us what line it's complaining about. So this is sort of like my standard Vim setup here. And I'm going to go ahead and get started with main.c. Now, because I'm going to be testing my ft.putCar function inside my main function, that's the reason why I'm creating it, that's the end purpose of this. I'm going to be writing this main function in such a way that it just does one thing and it calls my ft_putCar function. That is programmer speak for saying that my main function is going to use that function and the code that is written inside it. So the way that I will do that is a little bit trickier than normal, because the ft_putCar function isn't actually defined inside my main code file. So I need to do something to tell the compiler, when I compile this program from all the code that I've written, where to find all the bits and pieces. So I need to do a couple of things before I just go ahead and call that function. If I write a main function now, something like this, and main void, and I open it up and I do ft_putCar. Now I'm going to get to this in a moment, but this is going to expect a character, so it's going to look something like this if I wanted to make that character a capital Z. Sorry. Good question. Why do I put int and void? Well, the answer to that is partly because it's my main function, but there's a longer answer. So every function that we write has a few key properties. If we refer back to the exercise PDF here and have a look at what we've been given as the prototype of this function, it includes three basic pieces of information. And this is the essential data that your program needs about how this function is going to run. And it's also the format in which you write the introduction to the definition of your function, as I've done here in my main one. Now, the format that this is in is simply this. At the start, you specify the data type that the function is going to return when the function is finished. Now, a lot of the time when we write functions, they do things, but in the context of our C program that we're writing, they don't return any data that we want to reuse or manipulate. In the case of this putCar function, it's going to use write to put a character on our screen, but we're not getting anything back from that. Aside from the fact that we can see our screen, when I say we, I mean inside our C program, nothing returns in the form of data to the program that we called ft_putCar from. When we call that ft_putCar function, it's going to do a thing, and then it's just going to be done. It's not going to return any information about what happened, it's just going to do it. And the fact that we're not expecting to get any information in return when we run that function is why we put void here. If we were expecting it to return us some type of data, instead of typing void, we would specify that data type. So there are a number of data types that we need to understand to be able to get far at all in C. Fortunately, for most of this project, The main ones we're concerned with are integers, which are abbreviated to int, and characters, which are abbreviated to char, as you can see here, and indeed as is in the name of the putchar function. So, in fact, it is saying we're going to put a character on the screen, is probably the rest of that story that they've abbreviated there. And so, when we do that, we're not going to get anything back, and that's why that's void. So, but in order to put a character on the screen, we need to tell this putCharacter function what character to put. In fact, the reason that function exists is to be able to deal with a different range of characters and then just do what it does, put them there. So because of that, even though there's no return value once this is done, for this function to work, it does need an input. It needs us to tell it or to give it some data that will inform how it's going to operate. And so in this case, the one bit of information that putCharacter function needs to be able to put a character is what character am I putting. And so the bit that you're defining in the brackets here is the input to the function, but what's known more commonly as the function parameters. So parameters are simply bits of information about how that program is going to run. Now there can be more than one. In this format, you will quite often see multiple input parameters, and they will each be defined in this format with a data type followed by a name. Now in this case, the name that has been assigned to this parameter for use inside of the putCar function is just C. So what we know here is that when we give putCar a character, inside that program it's going to be known as C. Now that gets a bit confusing because we're already talking about C, the programming language, but in fact it is a common convention in C to use the letter C as an abbreviation for a character, or to use the letter S for an abbreviation for a string, so that's how it's ended up that way. But getting back to the original question, why is it main void? Well, following the same logic that we just used to unpack this prototype for the putCar function, we have basically some output and some input, or in this case, no input. So, answering your question back to front, the reason we put void for our main function is because we're not actually going to be inputting any data to that program when it runs. We're just going to ask it to run, and as you can kind of see here, the character that is going to be then passed to our putCar function is actually hard-coded into our main program. When we compile, assuming that we do everything else right and this is a valid program, when we compile this main function, it's not going to have the ability to do anything other than print as Z, because it's been hard-coded into the main function as Z. If we wanted our program then to be able to take a character that we pass outside of our program and then pass that on to the putCar function, then we would need to define some input to our main function and assign that to a variable, just like we do with the character C inside the putCar function. And then that information would be available to us again to use in the program in a variable way. Whereas this is never going to vary. You're always going to get a Z from the program that gets compiled from this code. So that's why it's void. There is effectively no input. Now, you will come across main functions which do require input, and they will have a special format involving something known as generally as argc and argv. I'm not going to get into that today, but you can basically use that method to receive one or more parameters from your command line when you execute your program, and then that data can be passed in through your functions to achieve some objective. But in this case, we're not writing our function with the ability to take an input, we're just hard coding a test case into our program so that we can test our function. So, as for the int, nearly finished answering your question, the main function is special. You might remember saying at the start, part of the reason is just because it's main. The main function must always return an int. And that's just a really old school convention to do with how C programs run. And when the program finishes running on your system will just expect it to return what's known as an exit status code. And that is a number which I believe can be anywhere from 0 to 255, but normally it's just either 0 or 1. 0 means that the program worked, that there was no error. 1 means that there was an error. But the important part of that for getting started here today is that anytime you write a main function, it must return an integer. Therefore, when we define our main function, we must start with int. So that's how we end up with this. Now, as I was saying before, I had that excellent question, and hopefully that was a useful explanation to answer that. We were trying to establish that we need to use this function, which isn't actually contained inside our code file that we're calling from. So we need to do a couple of things to put the pieces together. And that is basically to tell the compiler that there is more code in another place that it's going to need to use when it compiles our program. Now we can either give all of that information to the compiler when we compile manually, or we can include references to our other code inside our code files so that the compiler can use that information to find what it is. As I said before, I'm going to be making a main function that I'm going to try and reuse later. So I'm going to use the ladder method and embed the linking into my file so that I have less to remember later when I'm compiling my program. So how do we get a function from another code file into our main program? Well, we need to do two things. The first thing we need to do is include the code file which contains that code. Now, we're going to do this again in a minute, but it's going to look a bit different because we need to, in a minute, we need to actually do what we've been asked to do and write our ft_putcar function. And when we write our ft_putcar function, we're going to need access to a function called write, and we're going to need to get that from somewhere. But for now, we're just trying to get access to the function that we haven't written yet in our main function. So we're going to do it like this. Instead of using angle brackets, which is what we're going to do in a minute, to access a standard library, we're going to use quotes, and we're just going to put in the name of our own file that we've created here. And that's basically going to say to the compiler, if I go to compile my main.c, it's going to say, hey, there's also another file which has this name. You're going to need to grab that as well when you do this compiling. But C is super duper stingy with the amount of data that it wants to read and use. And so it's not enough to just say that there's more info in that file. We need to specifically say what we're going to use in the way of functions that are contained in that other code file. So we need to do one more thing, and we need to prototype any functions that we're trying to include from this other code file. Now, as I said earlier, we have been given the prototype of this function as one of our specifications. So we know what that has to be. We don't have to make any decisions about what to do here. It is as simple as, if we want to prototype our function, it looks just like that. Now, prototype is a special word because, and they've chose to use it here. Now, in this context, it gives us, as I said earlier, the basic information about how that function works. It's what it's called, it's the kind of data it needs to be able to do its job, and the kind of data it's going to return when it's finished. Obviously, any function that you actually write is going to contain code so that it can do stuff. But when you prototype a function, and in this context, we're prototyping it so that our compiler knows that it needs to find that function in our includes, we just give that much information, and we basically say to the compiler, trust me, there's a function here somewhere, these are the details you need for now. But long and the short of it is, if we want to link code from another file, we need to include that file, and we need to prototype our functions that have come from elsewhere. So, now we have a main function which will include a function that we just need to write. So let's go ahead and do that. Oops. Bet no one's ever done that before. Alright, so jump in here. And let's make sure we're in the right place. So I use terminal over iTerm out of habit, and I've used the keyboard shortcut just to say new window there to give me another workspace. Vim, of course, has lots of funky features. You can split one Vim window into as many as you want. But I'm still learning that, so I'm going to keep it simple and just use my GUI for that. So, I'm in the right place. We've got our main.c file. Now it's time to create, finally, at long last, the function that we're actually here to write. Oh my god. There we go. There we go. Alright, cool. Sorry. But good tip. Alright, so we are finally now at the stage of doing this thing. So we need to write a function that displays the character passed as a parameter. Now it's really useful to be clear about what this language is that's being used here. And we've already started to unpack some of that. So character, as we have established, is one of our data types. So when we pass our data to this function, we know that it's going to be a character, and we've got that further confirmed here because we can see that the data type of C, which is our one input to this function, is a character. Now, passed as a parameter, maybe you figured it out by now, we have already referred to this as a parameter, and I said before that when you use your function, you do something that is known as calling the function. And whenever you call a function that requires a parameter in programming speak, you are passing a parameter to that function. So hopefully that helps to sort of understand this very specific wording as it relates to the prototype that you've been given. Because there's a lot that's not been said about this exercise. But if you can learn to sort of read between those lines, they have actually given us quite a bit of information. So we know it needs to look like this. It needs to take a character. We know it needs to display that character. And we know to display the character, we must use the the write function as follows. Now, once again, we have been given some very specific specifications here. We might at this stage be inclined to understand how the write function works. And that would probably be a good thing if we could do that. But we already know how we need to use the write function. So whether or not we understand everything about that, we at least have some code that we can use to try and get somewhere. So I'm going to go ahead and use the information that I've been given, and I'm going to write this function to do just as it's told me. Seems pretty straightforward. I'm sure it's going to get harder, but let's take an easy win. But right away, I have to stop for a minute, because to be able to use a function that I haven't written, I need to include that function from somewhere other than my own code files. And what we have in C, and in many programming languages actually, but we're just going to focus on C, is a thing known as libraries, or standard libraries, which is to say sets of code, like collections of code that other people have pre-written that you can use to be able to make writing your code easier. Pre-written chunks of code that you can use to get somewhere with your program without reinventing it. Now, yeah, exactly. That's all nice and well and good, but that's not the 42 way. And we are here to make our own versions of a lot of very low-level functions that most C programmers would start out by having access to. In fact, if you go online and you look for some C tutorials, you will invariably see hello world programs which use the printf function. Now that's a very basic C function, but that's way too easy for 42. So we don't have access to that. We have to reinvent that wheel ourselves. And the only tool that we've been given to do that, as it clearly says in our instructions here, is a function called write. So a great thing to do right now would be to go and pull up the manual for write. I've already said we may not sort of fully understand everything about it, but it's nice to have some reference material available when you're using something like this. And so we're going to go and we're going to try and find the manual. But we have a problem. And that problem is that if we search for C right function, we're actually going to get a lot of stuff. And we're not necessarily going to get the function that we're looking for at the top of our Google results. Now, we do, fortunately, have a solution to this problem. As I mentioned before, every function that you use that you haven't written is going to be imported from a thing known as a library. So to be able to find the manual for this right function, we need to know which right function it is. How do we know which right function it is? Well, we need to know which library it comes from. That's really the key here. If it's not our function, we're importing it from a library. And it's probably going to be unique within that library, even if there's a million other functions from a million other libraries that have the name right. So we have one little missing piece of our puzzle. Now, there's probably a few ways to get there, but I used a time-honored trick and I Googled GitHub 42 machine to get a few little clues as to how other people have solved this problem. And it turns out that you can very quickly see that in order to access the right function, our friends from somewhere in the world, oh, hang on, that's the wrong one. Let's get the right project up. I don't think this is in the right order. Okay. Once upon a time, the machine was a little bit different, so I'm not finding that exercise yet. Sorry? We can. The question was, have I ever tried manning it, which is to say accessing the man page from the command line? Yes, and I'm going to get to that in just a second because that's a good question, and it's a very relevant question for our exam conditions. But getting back to my point, all right, I've found a solution to this, and I'm just looking for one clue. I'm not trying to cheat here. I don't want to do anything I don't understand, but I just need to throw myself a bone, and that is, which freaking library am I getting this right function from? And thankfully, I was able to find this little tidbit, which is the include of uni.std.h. Now, if we've watched a few C videos, and Benny is our friend, we've probably figured out that that is the format by which we include a C library. We've done something very similar to include other code already, but in this case we've included some code that we've written. So we've used double quotes to say this is the name of the file that I've got this code in. There are a lot, there are a lot of standard libraries that exist that will always be available to the regular C compiler. And so you can refer to those libraries not by the name of the file, but just with the angle brackets. And the compiler will look in its usual locations where it stores all its standard C libraries to find that. So we're basically doing the same thing. We're including a function that's not inside our main.c or our ft_file.c file, but instead of using quotes to import it from a file that is in our directory, we're just using angle brackets to name a library. Otherwise, it's the same thing. So now that I've finally managed to figure out where the hell I'm getting this thing from, I can go ahead and include uni.std.h. Now, quickly, bit of, yeah, that's better. Much better. All right, cool. Oh, get rid of the solution. I'm not trying to cheat too much. I'm going to make this up as I go along. See if I can figure it out. So, we have the prototype of the function, and we know that when we are actually declaring our function, we need to do the same thing, but instead of ending that, as we have there, whoops. See, has to be the same. Instead of ending that thought with a semicolon, as we did in the prototype of that function, we're going to go ahead and declare what that function does. And so that means that we're going to need a couple of curly braces and the code goes in between. Now, perhaps there's more to it, but when this function gets called, it's going to get past a character known as C. We're then going to reuse that C in this write command here. But I'm not yet satisfied that I know enough about what's going on. So I'm going to go back to this manual situation here and see, now that I know that we're using uni_std.h, I can do a much better Google search. And hopefully get fairly quickly to the right place. Now, just to make life easier, I can remember that I saw a really good one on a page called Wikibooks, so I'm just going to chuck that in as well. And aha, cool. But unistand.h we got right. I think we're on the right track here. So we have what purports to be the manual for write. Now, if we're on C00, we have absolutely no hope in hell of understanding everything that's on this page. That's a feeling that you're going to have to get used to. We are writing a fine line between learning as much as we can and keeping on swimming. But if we have a bit of a read and we try to match up some of the bits of information that we do understand, we might start to get a picture which makes sense. And that's a good feeling. So let's see if we can do that. So when we call our write function, we've been told very specifically that we're going to do it this way. We are going to pass it 3 parameters. Now, we haven't seen this properly yet, but before I said that when we are prototyping or declaring our ft_putCar function, that we have the output at the front, which in this case is void, because this function has no return value output, and we have an input between the brackets. Now, I did mention briefly that some functions will accept multiple parameters, and these can be different data types, int I, and you can have as many as you want there. Now, in the case of the prototype and the declaration of our function, we have had to specify the data type before the name of the variable where it will be stored. We've had to do that on both of those occasions, but now that that function is fully declared and we've got a prototype with those details in our main function, when we call our function, we don't need to mention that data type again. We just know that that function is expecting that data type. And that's what we've done up here. We don't go ft_putCar capital Z or char. We just put a capital Z because this function is already defined that the input is a character. That's always going to be the case. So that information is not only redundant, but it will confuse your compiler because it will think that you're trying to declare the function again. So we don't do that, but we also use that information to determine that what's happening here is that when the write function is being called, it's being passed 3 different parameters, and these are always comma separated. So that's what's going on. So we've got 3 parameters. We've got a 1, we have this weird NC thing, and we have a 1. So let's see what we can determine with that information and the specifications of the write function. So, much as we have done in prototyping and declaring our main and ft_putCar functions, we have here a prototype for the write function. Now, in this case, the write function has an output which is of the type size_t. Now, I mentioned earlier that there's a bunch of different data types in C. We're not at the point of needing to know what all of them do yet, but this is another one of them. Fortunately, one thing that you can usually infer from things like size and bytes is that it's probably a number. And, oh, hang on, that's the return value. So never mind about that return value, but hey, we can read our function prototype now, we know it's going to return that. I'm guessing that we're not going to use that return value because we've been told to use the write function in such a way where we're not assigning that return value anywhere. So I'm going to skip past that segment. Okay, we've got the name of the function. I'm not going to talk about that for too long. And now finally we have this really juicy part, which is these 3 input parameters with the comma-separated syntax there. So first up, we have an int, cool, finally in some territory that's familiar, that's called fd. We have this weird thing here, which, you know, I mean, weird thing in the middle, looks good. And then we have another parameter, which is size t, and I'm going to guess that the number 1 is probably a valid value for n bytes. Sort of makes sense. Now I'm going to read a bit more about how that might actually work. So we've got a 1 for this fd. It says it is the file descriptor which has been obtained from the call to open. It is an integer value. Well, I can understand this part. The values 0, 1, 2, ooh, hello, we've got a 1, can be given for standard input, standard output, or standard error. So I can kind of infer from that that if we're putting a 1 here, that means that we're writing standard output. Now, if I'd watched enough of the 42 videos on shell, I might have come across the idea that standard output is where the information goes that we see inside our shell. So that is a potential light bulb moment. Aha, we've been asked to display a character, and this write function has an option which we are using to write to standard output. Cool, okay, I think that kind of makes sense. Moving on. In the middle we have a weird thing which it says points to a character array, which can be used to store content obtained from the file pointer to environment. Okay, well, I'm going to focus on the bit that I don't understand, which is character, and specifically character array. Now, I'm going to pause very quickly to expand on my brief mention of data types before. So I mentioned that so far we're really just working with ints and chars, integers and characters. It turns out that for every data type, you can also have an array of that data type, which is simply to say a list of consecutive pieces of data that all are of the same type. So that's not something that we're going to be working with yet, but what this basically means is that this can accept arrays of characters. Now, we're looking to print a character, so once again, without fully understanding this, I'm feeling like we're on track here, and then I'm starting to get an idea of how this write function is actually going to work for me. Finally, we have n bytes, which specifies the number of bytes to be written from the file into the character array. Yeah, okay, well, if I was to remember when I was learning about data types that the character data type uses 1 byte per character, then I might be able to infer from this that the number of bytes that I specify would correspond to the number of characters that I'm looking to print, which may also help me make sense of the fact that it's looking for a character array. In fact, we can specify how many characters to print, so it sort of makes sense that an array could be a possible input. So, once again, I'm not going to try and demystify this whole page, but I just wanted to share a bit of a thought process I went through to try and put these puzzle pieces together. And it really helps to drive home the syntax of a function prototype and the significance of what the data types are that are being declared for that function. So anyway, we've got a bit of an idea that we're doing a thing which, I mean, we're doing what we've been told to do. So I feel like we should see if we can get this code to run and see how close we are to a solution. So I'm going to go ahead and write my files out with Vim here. And I'm going to keep those open because I've got a bit more space to play with on my screen. I'll jump into a new window, and I'm maybe getting a bit carried away because there could be some errors still, but I'm going to have a go at compiling this program. I'm going to use the GCC command. I'm going to tell it that my main code file is main.c, and I'm going to give it an output file name of ex00-test because, well, that's what this program exists to do, is test our function for this exercise. Away we go, and no errors, that's a good thing. Let's see what we've got. I'm going to try and run this program. no, dot slash ex00.test. Can anyone tell me why I am typing dot slash ex00.test? Well, in fact, this is telling the computer that the file ex00.test that I'm trying to run, or the program in this case, is located inside this folder. Dot in shell simply means current working directory, the folder that you're in. Another way of figuring out what that is to type pwd, which of course stands for print working directory. So dot is merely a shortcut for this folder. And if I want to run a program, something like ls, that's a program that's been installed on my computer for all intents and purposes. And so the computer knows that when I run an arbitrary command name to look in the places where programs are normally installed to find those commands. Because this is a program that I've just compiled that's just sitting in a folder on my desktop, the system is not going to be looking there for commands unless I specifically tell it that's where that command is. And so that's why, in this context, I have to put a dot slash before my name to say run the file or program ex00test in this folder. And let's see what we get. Wow, we got a Z. That's pretty cool. We really haven't done much, but we have done what we've been asked, and we have stuck very closely to the specifications of the exercise. And blow me down, we seem to be getting an expected result. Let's just quickly check that. We've written a function that displays the character passed as a parameter. Well, we have a character, which is a capital Z. We've hard-coded that into our test main function, but then we've passed that character through to the ft_putCar function. It's coming here as the car known as C. And then we have used the write function to write that character out to standard output. All right, cool. I think that makes sense. I'm not really satisfied yet, though. I didn't go to all this effort to create a test program just to run one test. So I'm going to try something different and see if it still conforms to what I'm expecting. And go ahead and change that to a completely different type of character. It's going to be the number 4 because we don't have enough room to do 42, sadly. And so that I don't, oh, hang on, no, I'm gonna go ahead and run my program again. What I got is that. Can anyone tell me why? That is right. Anytime you make a change to your code, you need to recompile your program. The program is still a copy of whatever was in your code file when you ran the GCC command. So one little tip that I've got for when you're testing your programs so that you can avoid running into this common error is to actually chain together your compile and your run commands. And you can do that on the shell just by going GCC, blah, 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 however you want that, and the program name to run. That way, every time you go to test, you can use the up arrow, you can hit enter once, and you know that the test run of your program has come from a freshly compiled copy of that program. It's always going to have the latest changes that you've saved. Sorry? What happens if we pass through an integer? Good question. So let's perhaps give that a go. Well, I mean, that's an interesting question because if we're going to pass through an integer, it's not just a case of passing through a number. An integer means something very specific in C. An integer is another data type. An integer is very specifically not a character. And in fact, an integer is stored in 4 bytes, whereas a character is stored in 1 byte. So if you try to pass an unexpected data type, a couple of different things could potentially happen. I mean, basically, it's not going to work, but it's going to interpret that information, which is stored in 1s and 0s, in the wrong way, because it's expecting a character when you're giving it an integer. And if you're potentially pointing to memory addresses and things, it might even be reading the wrong part of that data, because if it's a 4-byte chunk and you're expecting a 1-byte chunk, you don't know whether you're getting the start or the end. There's a few reasons why, very quickly, that just doesn't work. So we could test that. And in fact, seeing as you've asked that question, let's just go ahead and see.
Basically, it's how much the program is expected to run through. And the last one is the device that is allocated itself to be allowed into the first run that you have. So if you want an integer, you can declare the integer in the second parameter. So that it knows what it's working with, and then give it enough space before you can further.
So it's a fair question. Let's see what happens. So if we declare an integer, which is what we'll need to do to be able to pass that data type into the putCar function, we're going to call it test int, and let's assign it a value. It's an integer, so well, we can do 42. Cool. So instead of printing literally the character 4, which has been put in single quotes because it's literally the character 4, not the name of something in our C program, but instead I'm just going to put instead I'm going to put test int. And I'm not going to put it in quotes because I'm referring to the name of a variable that we have stored. So I've done two things here. First of all, I've declared a new variable. Now, this is very similar to when you declare your input parameters for a function. In fact, it is in the same syntax of data type followed by the name. Now, because we've declared the putCar function with carc up here, as soon as this function is called with that relevant input, the variable is automatically assigned from that input. It's declared and assigned from that input. Here, we're again just hard coding something in to see what happens. So, yes, you're quite right. All right, that's what you meant. Thank you. Cool. Errors do happen. All right, cool. So, does that look more like valid code to everybody? Sweet. Now let's see what happens. Oh, we got a star.
Processing as a character.
Is that what you were expecting?
Yes.
All right, so why would that be? Have I heard of ASCII? Well, we've run into an interesting scenario here because in this case, we are getting what we think is an expected output from a mismatch of data types. But if we were to fully unpack this issue, we might find that this outcome is dependent on the type of operating system that our C program is running on and how memory and data is stored within the way that that operating system is designed. Now, this is a concept known as alias, and I don't really want to confuse you too much with it at this point, but it's probably dependent somewhat on the compiler as well. But basically, if you have a 4-byte data type and you're looking for 1 byte of data within that 4 bytes, you're going to have a sequence of bytes that are organized from most significant to least significant. That means that the big part of the number is going to be at one end, and the little part of the number is going to be at the other. And on different systems that are all valid systems for running C programs on, that could be either way around. And that's, as I was sort of saying before, there's a few reasons why you don't really want to mismatch data types, but that's a really big one. It's because even though we're getting an output which is sort of consistent with what we're expecting to happen, we are mismatching data types, and that's not really a good thing to do. So because we know that the right function is expecting characters, it's quite important for us to get the expected result for us to only pass the characters. Now, to go into that a little bit further, if this write function was purely a C function, and we were just passing C to it here, and that was supposed to be a character, we would get a compile error. But when we use the write function, we're actually making a call to our operating system, which is outside the bounds of our C program. So we're just pointing it to a part of the system memory where we have stored that variable. Now, I believe what's happening here is because we have stored our 4-byte int in a little NVN segment of memory, when we've pointed to the start of that and grabbed the least significant bit, it has happened to be the correct value. But that is not guaranteed. And when you start working with buffers and you start unwrapping variables with the ampersand and doing things where the compiler is not going to stop you if you use the incorrect data type, you need to be even more careful. So yes, you can use an int and you can pass it through in certain conditions to get the expected result, but I would strongly recommend you do not do that if you want to retain your sanity.
It's just like if you do it, yeah, it's
Okay, now I see what you're getting at. Now you might think that, but in fact, what's happening when we store a character is that even though we know through sort of like what we're demonstrating here that we have this ASCII code table so that a character with the value 66 is a capital B, in the background, every single bit of data that the computer is storing is ultimately just ones and zeros. And to make those ones and zeros useful, they get squished together to represent numbers. But they only ever represent numbers. And we have to do something to make that a more human readable output. And that's why we have the ASCII table, is so that we can take ones and zeros, which will ultimately represent a number, and display a character instead so that we understand what that means. Now, if I declare test int here as a character, I can actually still assign that value a number. Now, that number fits the description of an integer, but actually what happens when I assign 48 to testing is 48 gets converted into the requisite sequence of zeros and ones and stored in 1 byte of memory as a character. So even though this is not an int, that this is a car, this test int, I can still do things like test int plus plus. And that's just going to add 1 to the numeric value that underlies that character data type. And I would go from 0 to 1. In fact, let's check it out. So let's write that out. And let's see what happens. Oh, I got a 1. So as you can see, even though I put in a 48 as a character, that's completely valid. And as you said, we need to be able to perform mathematical operations on these characters to be able to iterate through loops and do the kind of things that computers are good at, but with characters. So, good point. We do want to be able to use the numeric value that represents our characters to be able to program using those data types. But don't confuse the fact that that data type is stored as a number, because they all are, with an integer. Because an integer is specifically a lot more than that in the context of C. Is that sort of making sense? Yeah. So basically, do what you've been doing, but just use cars. Don't use X. Cool. All right. So, 42 minutes, huh? That was pretty ambitious. Well, you know what? I've got a working program. I've been able to test it. We've unpacked a few really cool concepts. And I hope that this has been useful for you, at least making a start on your C journey here at 42. This bit that came up about the ASCII table, pay note to that, because if you get past EX00 and you get much further, you're going to need to use these tricks that we've just sort of been referring to about adding numbers to characters. And use the man page. Now, one more thing, real quick, before I finish. The question was asked earlier when I was looking for the manual for unistandard.h/write as to whether I tried looking in the man. Now, it turns out that if we man write, we get something completely different. This isn't even a different C library. This is just nothing to do with C. This is more to do with the operating system we're running, which is Mac OS. Now, underlying Mac OS is a thing called BSD, and the default man that we have is a thing called the BSD General Commands Manual. Once again, nothing to do with C. Really useful for getting information about our shell commands, which are all pretty much contained in this manual, but no good for C. Having said that, if we do something like man printf, which we kind of know is a C function. Oh no, there's a BSD version of that as well. Alright, what have we got? String length, that's a function. Oh. No, that was another BSD thing. Alright, anyway. If oh, sorry, string length, that was the one. Oh, yeah, sorry, I read this wrong. So, yeah, this has come to the right place. Now, there's a clue here, which is that where there used to be a 1 for our BSD General Commands manual, there's now a 3, and it says BSD Library Functions manual. And we're actually talking about the standard C library. So, there is not just one man on your computer, there is at least 3. And if you do man 2, you're going to get a BSD system calls manual, which is actually a C library, and that includes stuff like write. But if you do man 3, you're going to get actual standard C library functions, not ones that are specific to Unix, not BSD commands, but actual C library function stuff. So if we use that and go man 2 write, we can actually get some information within our exam environment about functions like write and the prototypes and further details. Now, the reason that I've gone to the internet for this demonstration and looked at a nicely formatted web page where we have syntax highlighting for our prototype is just to retain my sanity. Now that I'm familiar with this function and this layout, it may be useful for me to pull this up in the exam and just refresh my memory a little bit about this write command. And especially, don't forget man ASCII, because that's really going to help you in the exam. All right. Any more questions? No? Cool. Thanks for coming, everyone. Yeah, we took a while, but I think that was pretty good. So, yeah, thanks for coming.
Thank you.